All right, so page 17 in your packet, we're going to do the morning test review. And if we have time, we can also do a little bit of worksheet 4 as well. Just want to pick out as many problems as I can. So. All right, so number 1, let h of t equals f of g of t, find h prime of 1. First things first, we got to find the derivative function first before we can evaluate the derivative. So we need to find the derivative, h prime of x. Okay. We need to be able to recognize this as a function within a function. We have to apply chain rule here. The chain rule says outside's derivative multiplied by inside's derivative. Outside's derivative is the f function. Leave the inside alone. Then multiply by the inside's derivative. All right, make sure you take the time to include the original inside function. You say f prime of g prime, that's incorrect. You gotta follow the chain rule here. Outside's derivative, inside intact, multiplied by inside's derivative. Okay. Now replace. Now we can work towards involving that 1. Replace every t with 1. Sorry, it should be h prime of t. Okay, so one step at a time here. Right now, it's still too complicated to be able to get to your answer from here, but we can kind of take steps towards it. So let's go ahead and find the parts that are actually manageable. And that is, we can find g of 1 and g prime of 1. So we'll find those pieces, make the substitutions, and we should be able to have an easier problem on hand. So let's find g of 1 and let's find g prime of 1. I'll go ahead and put that over here to the side. G of 1 is equal to 3. G prime of 1 G prime of 1 is whatever the slope of this point is on this graph. So I'm looking between this point and this point, and I'm seeing that it looks like it's a slope of 1, but it is kind of confusing because on either side of this point, it looks like a slope 2 on one side and the slope 1 on the other side. So I'll be a lot more clear on the test. And if it's not clear, then you can choose which, whichever option you want to do for your slope, because it's not very clear. But here I chose to do slope 1. Okay. But if you did slope 2, that would have been acceptable as well. But on the test, it won't be vague like that. Does that make sense? So g prime of 1, I'm looking for the slope of this point. It should be a straight line. There's a curve here at the end. I'm going to say it's a slope 1, but you could also say 2. So now, once we found our g of 1 and our g prime of 1, we're going to make our substitutions. Remember, we're still not quite at the answer yet, but we are going to make progress here. So rewrite everything, okay? Rewrite everything you see, because we haven't resolved that f prime yet, but we have found what g of 1 is, which is 3. Yes.
I think you mixed up the graphs.
Oh, I did. Sorry.
G of 1 should just be 1, I think.
Oh, sorry. I did mix up this graph. Sorry. G of 1. My bad. I was looking at the abstract.
17 on attribute.
My bad, sorry. So g of one is one, and g prime of one. Okay, so g prime of one, this is a slope of what?
Negative.
Okay, so this is clear, right? This is slope negative. Okay, so f prime of g of one is one. G prime of one is negative one. Okay, so this is where it's confusing. F prime of one. So we're almost there at the end. F prime of one, that's this point here. So now f prime of one, you can, yeah, so here you can either say slope one or slope two, because it's not very clear what that slope is. So I'm going to say that it's slope one. Or if you decide to look on this side and you think and you want to say that it's slope two, it's also acceptable. But it will be clear on the test. Okay, typically with the graph problems is the chain rule that kind of trips students up. So any questions here? First, building chain rule, that's one issue. And second, making the substitution or trying to get too fast to the answer, trying to get from here down to the answer without, taking those intermediate steps. Yes.
Or could you just put -2? Yeah, also.
No, it's either one or the other, but on the test, it won't be vague like that. So you're only going to get one answer on the test. Hello. Okay, number two, let z of t equal f of t times g of t. So now this is what I want to find the derivative.
Product.
This is product rule, okay. Notice that even though they both involve f and g, this one has two t's in it. So that tells us that we have two distinct functions outside of each other. Here, there's only one t. This is a function within a function. Product. Okay, page 17. Okay, replace every t with 3. Now we go to our graph, right? We're either going to pull the slope of the f graph at 3, or we're going to pull the slope of the g graph at 3. Or sorry, the slope or order pair of the f or the g graph. Okay, so first up is f prime of 3. So f prime of 3, that's the slope of the f graph at 3. Slope of -1. Okay, g of 3, we're now looking for the y value of the g graph at 3, which is 1. F of 3 is 3. G prime of 3, the slope of the g graph at 3 is +1. -1 plus 3 is 2. Okay, any questions with 1 or 2? All right, number 3. Consider the curve 2y cubed plus 6x squared y minus 12x squared plus 6y equals 1. Show that the derivative is this. So this is what the answer should be, but we're starting with this equation up here. Okay, we need to be able to look at this equation and understand that we have implicit involved because you have y's kind of mixed into the equation, right? The y's look out of place. Doesn't look like how we would have it set up as a function. So we definitely need implicit here. What else do we need here?
Product rule.
Product rule, right? It's not announcing itself, but we need to recognize when product rule is required, especially if your x and y are next to each other being multiplied. Now, notice that this one's a little bit easier. There's no minus sign in front of that product rule. If there was a minus sign, I would definitely protect that with a set of parentheses, because once that gets expanded, the negative has to distribute through it. But here, that plus sign is not going to impact it. But if there was a minus sign, I'll put a parentheses right there. Okay, so implicit and product rule. So we can start our derivative process. Most of the other terms are just going to be power rule. Okay, so 2y cubed becomes 6y squared. We just took y's derivative, so we need to immediately attach that dy dx. F prime g plus f g prime. Six x squared becomes 12x. G function is the y. Back to f. G prime. So g prime, the derivative of y is 1. We can attach that dy dx. All right, keep going, right? We have a couple more terms that we have to complete. So next up is 12x squared. Derivative there is minus 24x. 6y becomes 6. Don't forget your dy dx. So I'm starting with y, need a dy dx if I find the derivative. Okay, and then 1 goes to a 0. Sometimes students leave that 1 there thinking that it's only the left side that they're taking the derivative of. You're taking the derivative of both sides of your equation. So that 1 goes to a 0. Let's do some cleanup here. I have 3 dy dx terms. I'm going to try to leave them on the left side. All the non-dy dx terms. The other 2, I'm going to leave it on the right side of the equation. Now that I have my dy dx terms separated from the terms that do not have dy dx, I can take that dy dx out of every term. Divide that parentheses over to the right side. I will accept if your answer is unsimplified. That means if there's a GCF that can be taken out, but you didn't do it, I would accept that, but you can also go a little further by taking out a GCF of 6 out of everything. And then do some cleanup and leave your answer like this. Oops. My bad, over here, I messed up. The derivative of 6x squared should be 12x. I lost that x there.
Does the x in the denominator of this, or is that supposed to be squared too?
Which part? Oh, yeah, this part. Yeah, I bet. X squared, I lost that x squared there. I did it wrong. Number 4, let me change this problem a bit. It says find the second derivative. So it's going to have us find the first derivative, but I'm going to change this up a little bit. So if we can change this here, we're just going to find dy dx. Let me change this to be raised to the 4th power. So there's a combination of rules here if you want to find this derivative. And can you list out the rules that's involved here? We got to involve what? Chain and quotient, okay? Which one comes first?
Chain.
Chain rule. The way you can tell is you look at the parentheses. If your parentheses says over everything, it has a further reach than the quotient rule, and the rule that impacts a larger portion of the problem is going to come first. So chain rule come first. Once you get out of the chain rule, or once we're inside chain rule rather, then we can get into that quotient portion. Okay. So chain rule says outside versus inside. So outside function is that parentheses to the 4th. Inside is that x minus 1 over x plus 2.
So why did you say you could change this to me?
Because the parentheses is over the entire problem.
Okay.
But if the parentheses is only over a portion of the problem, then we want to apply the other rule first. Whichever rule has a further reach, has a larger impact on the problem, comes first. So chain rule first, followed by quotient rule. Okay. So outside derivative, what does parentheses to the 4th become?
4 parentheses to the 3rd.
Okay. And what goes inside here?
X minus 1.
Yeah, we don't want to do derivative just yet, right? So now that we've taken care of the outside portion, now we're ready for the inside derivative, and inside derivative is where we're going to activate chain rule. Sorry, quotient rule. That's numerator denominator. We got to do quotient rule there. Okay, f prime g minus f g prime all over g squared. We go through our derivative process. F prime, x minus 1 becomes 1. G function, no changes. F function, no changes. G prime becomes 1. All over denominator squared. Okay, so there's our derivative. But we're gonna do some more cleanup. Any questions with the calculus portion? Okay,
Wouldn't G prime be free?
why do you say that?
Because X would go, oh,
X would go to 1, right?
Yeah.
And 2 would go to a 0.
Got it.
Okay, so no questions with the calculus portion here? So now let's clean up. Okay? So let's talk about cleanup in this, in a way that I see some students do it. Can I ever do this? Can I ever take one of the x plus 2's out? No, why not? There's a minus sign, right? This is preventing things from being removed. That minus sign, plus sign, anytime things are added or subtracted, it's not easy to just cancel out between numerator and denominator. So what that means is we're going to ignore the denominator. We're just going to clean up the numerator as we see it. So we're going to distribute, do some cleanup. Now, as we do that, let me also talk about what is helpful. This cubed here, okay, does the cube only see the x minus 1?
No.
These denominator as well. So I think something that we can do to kind of help us make sure we don't miss it is write it out with that exponent 3 twice. It seems redundant, but it's going to help us know what is happening with that denominator. Otherwise, we may misinterpret this x plus 2 as if the 3 is only seeing the numerator. Right, so that's an extra reminder that, oh, there's 3 x plus 2 down there. All right, so here's my cleanup here. Distribute the 1 through. I get x plus 2. Distribute the negative 1 minus x plus 1. So we're almost there. Now we're just trying to push everything into one fraction here. The 4 and the x minus 1 cubed stays up top. What happens with this? X plus 2 minus x plus 1. What does that become?
Sure.
Okay, just 3, right? The x's go away. 2 plus 1 is 3. Now, what happens here at denominator? Is it x plus 2 to the 6th? Fifth, right? We add exponents. We add exponents, right? And imagine if we didn't do that with that extra step, I think a lot of students would say, oh, that's x plus 2 to the 3rd power. Because I see 1x plus 2, I got 2 here, I'm going to add them together, I get 3. But that 3 there, it's helpful to rewrite it in the denominator to remind ourselves, oh, there's 3 down there, 3 plus 2 is 5. So there's my slope formula. I'm just going to merge that 4 and 3 together.
Why did you put f(x) to
Oh, why did I put it to the 3rd power?
to the fourth, like at the very.
Oh, yeah, sorry. So I changed the problem. So that rather than find the second derivative, we're just going to find the first derivative of this problem, just so I can get that practice with you guys.
Okay.
Next page. Okay, particle motion problem. X of t, you got a position function. T is greater than or equal to 0. 5 when the particle is moving left. Before we can do anything with movements, we got to get down to our velocity. Okay, create our velocity sign line. Set velocity equal to 0, find the t values where the particle is at rest. So all that information we need to find before we can get that sign line going and actually read it. Okay. So let's find our velocity function. Power rule for every one of these terms here. Okay, set velocity equal to 0. Factor out that 3. So for t, I get t equals 1 and 5. Okay, so now we can populate our velocity sign line. Now we are, even though 1 doesn't show up for velocity 0, it is showing up as an endpoint, as a restriction. So we are going to include 0, 1.
How's the greater than or equal to, would you put a bracket? Is that what you know, to put a bracket?
Yeah, that's when you know you have to involve a bracket.
Okay.
Yeah. But yeah, that's right. Because we know that 0 is part of my domain. So if there's movement at 0, then we need to include it with whatever movement is happening here.
Put a-
Right. Everything else is parentheses. The 1 is parentheses, 5 is parentheses, and infinity is also parentheses. The only time that 0 would also be a parentheses if for some reason 0 showed up from velocity 0. Right? Let's say t is equal to 0, 1, and 5, then 0 would have also been a parentheses. But because it's not showing up as velocity 0 and it's included in the domain, we know there's movement there. Okay. So now we're going to pick points in each subinterval, pick numbers in each subinterval. So I'll choose 1/2, I'll choose 2, I'll choose 6. Insert into the velocity function. Remember, you're testing velocity sign lines, so it makes sense that we're going to be involving the velocity function. I like the factor form. Factor form feels easiest to plug in without having to do a whole lot of calculations. So I'm going to ignore that 3. That 3 is always positive, so it's not going to impact my sign. Just the t's. So 1/2 minus 5 is negative. 1/2 minus 1 is also negative. Negative times negative is positive. So I know that between 0 and 1, my particle is moving to the right. Okay. Insert 2 in. 2 minus 5 is negative. Minus 1 is positive. Negative times positive is negative.
Why did you write 0 as one of the roots on the
Because it says our domain is t is greater than or equal to 0, which means that there's no negative numbers. So we need to have a starting. It starts at 0, right? Now, if it doesn't give this information, then we would leave 0 out, and we would also include negatives in our sign line. Here, it's restricting our sign line to just be 0 and positive numbers.
Okay.
Okay, 6 in for t. 6 minus 5 is positive. 6 minus 1 is positive. Okay, so I see students on the quiz, they did everything right here, but then they wanted to involve the 1/2, 2, and 6 somewhere in their answer elsewhere. So just know that the only purpose of the 1/2, 2, and 6 is just to fill the sign. After that, it serves no purpose at all, and you don't want to use these numbers ever again. Okay? If anything, you're only going to use 0, 1, 5, and infinity. Those numbers are just to get the signs going, and we don't really care about those numbers anymore. Okay, particle moving left, we see that is between 1 and 5, parentheses on both sides. I'm not asking for justification for this problem, but on the test, if I ask you for justify your answer, you would say because v of t is less than 0. Okay, part B, is the speed increasing or decreasing at t equals 2? Well, what's the strategy there?
There's times in A2.
Yeah, we got to look at two things, right? Speed increasing, that means we can do velocity and acceleration, compare their signs. Are they the same signs or are they different? If their signs are the same, one is positive, the other is positive, or one is negative and the other is negative, then that's going to indicate increasing speed. But if one is positive and the other is negative between velocity and acceleration, then we know speed is decreasing. So, but that means we have to work our way down to our acceleration function. So I'm going to just gather that information. A of t equals. So here's my velocity function. This is the easiest one for me to find the derivative without all the parentheses. So power rule for each term, 6t minus 18. So I'm only testing for one particular point. So I'll say v of 2 and a of 2. So v of 2 technically, we don't have to find that value, just have to test whether it's positive or negative. So v of 2, well, actually, we can tell by looking at this, right? V of 2 is going to be negative. So v of 2 is less than 0. A of 2, plug 2 in, 12 minus 18, it's also negative. So velocity is negative, acceleration is negative. So that's same signs, therefore speed is what? Okay, part C, find the average acceleration. So anytime you see the word average, you know that there's something tricky going on here. Let's review. We've seen average velocity, right? How do you define average velocity? Change in position over change in time. So average velocity, we're going to take the function above it, right? So the one above it is position. So you got to do change in position over change in time. So in much the same way, average acceleration, we're not going to touch acceleration, but we're just going to involve what?
Velocity.
Just velocity. It's the change in velocity over change in time. Because acceleration is defined as the rate of change of velocity, we're going to just understand this is only asking for the slope between the endpoints of the velocity function. So average acceleration is change velocity over the change in time. Okay. The tendency is students realize that, oh, it's slope, and why not use acceleration? Because I see that word there. So they will do a of 2 minus a of 0 over 2 minus 0. But you're not going to touch acceleration at all. You're just going to involve velocity. So v of 2, insert 2 into the velocity function. You'll get -9. 0 into the velocity function. You'll get 15. Now, this problem doesn't provide units, but let's say if it was like meters and seconds, then, or whatever we will say, yeah, whatever the unit is per second or per ton units squared. Just understand that even though we're not touching the acceleration function, our units are still going to be involving something and will be still acceleration units. Okay, where's the particle located when the velocity is 0? Well, velocity is 0, we know that from before, right? Velocity is 0 at 1 and 5. So we just want to know where's the particle located at 1 and 5. So how can I do that?
Plug in x5 also.
Into the
Position.
position, yeah. Okay, so we can use our calculator, or sorry, X. I'll use S, but. Okay, why don't we use 0.5? It says when velocity is 0. So where's velocity 0? Well, we gathered that from part A, right? Velocity is 0 when t is equal to 1 and 5. So we're just kind of pulling that information from before and using that information. Okay, so x of 1 into the position function, we'll get 10. X of 5, plug 5 into the position function, we'll get negative 22. Okay, find the particle's displacement. So what's the formula for displacement?
Solution.
Say it again.
Final minus solution.
Yeah, so it's of what? Position or velocity?
Position.
Position, good. It's final position minus initial position. We're not going to touch the velocity function. Okay, so, sorry, I keep using S. Okay, so 3 into the position function, 0 into the position function. That's negative 6 for x of 3, and 0 is 3. So negative 6 minus 3 is negative 9. It's okay to have a negative displacement. That just means that you end up to the left of where you started. Okay. Now, finding particles distance, this requires a bit more work, but we're going to start with the same information that we did with displacement. It's just that if there is a change in direction, we're going to have to do a little bit more involvement with that. So we know we're still going to involve x of 0. We know we still are going to involve x of 3, but we may include other t values depending if there is a change in direction somewhere between 0 and 3. So we go to our velocity function. Is there a change in direction between 0 and 3? Yes, right, and that's 1. Okay, so we're going to involve 1. Well, there's also change in direction at 5, but why don't we want to use this?
They say only 3.
Right, we're stopping at 3, right? We're not going all the way to 5. We're not going all the way to 6. If we're going all the way to 6 or 7 or 8, then we would involve both 1 and 5, but we're only involved, what's between our endpoints. So we have information from before, right? X of 0 is 3. X of 3 is negative 6. So now we need to find the position of the particle at 1. So insert 1 into the position function. 1 minus 9, negative 8 plus 15. 7 plus 3 is 10. So we have to know how to work with these numbers. We're not just going to add all these numbers together. We're just going to think in terms of these are locations on your number line, and you're just traveling between these points and you're counting your steps. So negative 6 is down here, 3, and 10. Okay, so you're walking from 3 all the way to 10 first. That's the first leg of your journey. And then from 10, you're walking all the way back to negative 6. That's your second journey here. And all the while, you're just imagining yourself counting your steps, each step you take. And if you're going, doesn't matter if you're going to the left or to the right, you just have a running total of the number of steps you're taking. So what we can do is we can subtract these numbers, right? Get that distance. So between 3 and 10, what's that going to be?
That's
7. Okay. And then between 10 and -6,
16.
right? So I'm going to go from 10 to 0, and then from 0 to -6. That's 10 steps. That's 6 steps. 10 plus 6 is 16. So after everything's said and done, how many steps have we taken? 23. That's your distance. I see students involving negative numbers. I see students trying to add all these numbers together. You just have to imagine yourself on a number line and you're just walking between those destinations. Okay, part G, is the velocity increasing or decreasing at t equals 2? This is also tricky as well. Is this talking about velocity? No, it's talking about acceleration. It's the increase or decrease of velocity. It's the rate of change of velocity. It's really acceleration. So all we care about is looking at acceleration. Acceleration at 2 is 12 minus 18 is -6. That's a negative number. That's less than 0. So negative acceleration indicates what? Velocity is decreasing. Yeah. Okay, find the velocity and position when acceleration is 0. So we first have to get that t value first, right? I want to figure out when is acceleration going to be 0. So place a of t with 0 and solve for t. There's my acceleration function. Solve for t. So there's the time when acceleration is 0. Now I want to find velocity and position at that time. Okay, number 6 and 7. Yes, question. Yeah. I can say velocity is decreasing at t equals 2. I think maybe that's better. Velocity decreasing at t equals 2 since my acceleration is negative. That's fine too. Yeah. Okay, number 6. Okay, number 6, asking for the derivative. This is also a combination of 2 rules. Can you identify those 2 rules? Product and chain. Product, because you have 2 separate terms. Chain, because I see the parentheses. But now the question is, which one is going to take priority? Which one is first? Which one has a larger reach? Product rule. The reason that we know that is because the parentheses is involved with chain rule, but it doesn't see the entire problem. It's only a smaller portion of the problem. So therefore, chain is going to come second because it's not over everything. The product
What
rule.
do you mean by that? It's not over.
So something that would be over everything would be something that's like this.
This one.
This would be an indication where I see product rule and I see chain rule, but you see parentheses over the entire problem. This is chain rule first, followed by product rule.
Okay.
Here, product rule is going to come first. Okay, now this is a square root of x. We know square root of x is the same thing as x to the 1/2. So I'm just going to go ahead and put that to the side and understand that I'm going to just jump into my power rule there. So what's the derivative of x to the 1/2? Yeah. The function. Back to f. And then g prime. So when we get to g prime, now we see the parentheses with terms inside, the exponent outside. So chain rule is going to get activated here. So outside is my parentheses to the 4th. And inside is that x cubed minus 7. We take turns with each derivative and we put it all in the space. Parentheses to the 4th becomes 4 parentheses cubed. What goes in here?
X to the 30 minus 7.
Right. We don't want to do too much all at once, right? We don't want to put the derivative in here. We're just going to leave that inside alone because it's going to have a space for its own derivative, and that's going to be coming up next. Times, now we're ready for inside derivative. Now we can put what? Okay, for this problem, I'm not going to ask to do too much cleanup, but we'll just do what we can. Complex or with no common denominators is fine. I'm just going to try to put things together here. 12x squared.
So is it okay if we leave it like that?
That's fine.
How did you put x cubed on 7 to the 4th over 2x to the
That's not gonna be-
So I want to put all these together, right?
Yeah.
So I'm just going to put what belongs in the numerator up in the numerator and what's in the denominator. So we're good with this x cubed minus 7 and 4. That's definitely in the numerator, right?
Yeah.
This 2 is in the denominator, right? 1/2.
Oh, okay. I see.
And then the x to the negative 1/2, I can also push that down to the denominator to get that negative exponent to be a positive exponent.
Oh, yeah, I see what you're saying.
All right, number 7. All right, so first things first, I want to get that radical to look a different way. This is also a combination of 2 rules. What are they?
Quotient and chain.
Quotient and chain. Which one comes first?
Quotient.
Quotient, right? that parentheses is not over the entire problem. If it was, then chain rule would come first. But here, quotient rule has bigger impact on the larger percentage of the problem than that parentheses. Parentheses only over a portion. It's gonna, the larger rule is gonna, the bigger rule is gonna come first. So quotient. Once we're inside quotient, then the parentheses with the chain rule gets activated. Okay, so we said quotient rule first. Now, as we start quotient rule, we see that chain rule is going to get activated within this F prime, right? So you have a larger space there for. Okay, so F prime, this is where chain rule is going to get applied here. Outside portion is that parentheses to 1/2. The inside portion is that 2 minus x squared. So that outside derivative first. Parentheses to the 1/2 becomes 1/2 parentheses to the negative 1/2. Fill that space in with the original 2 minus x squared. Times, now we're ready for the inside derivative, so times what? Negative 2x. Okay, so now we're done with f prime. Now move on to g. Original denominator, no changes. Okay, back to f. Prime, 4 plus 3x becomes
3.
just 3. All over my denominator split. Okay, cleanup. So the calculus is done, but we're going to do some cleanup here. Can I ever do this? It was tempting, right? You see top and bottom matching. Why not cancel it out? That minus sign is preventing us from doing it. So the best we can do is just look at the numerator, see what we can do to clean up. Now, we have two connected pieces here, right? You got this piece that's connected, this piece that's connected in the denominator. Now, all this, there is a negative exponent, and the tendency is, oh, I got a negative exponent, I'm going to push it down to the denominator. Again, we can't do that because that minus sign is preventing. So what we can do, though, is we can put this in the denominator within this own little space. So it's going to kind of create that complex fraction. But I'm going to try to do some cleanup before we get there. You see that 1/2 and negative 2? You can get that 2 to go away. And I can put these three things together, the 1, the negative x, and the 4 plus 3x together. But I'm going to put this in the denominator of this little space here. So I've done a little bit of cleanup here. I was able to get this mess as at least a fraction within its own space, but I'm still staring at a complex fraction. So I want to get these two to merge together, but I can't merge them together unless they have the same denominator. So I'm going to step to the side and try to get this cleaned up. So what's my common denominator between these two fractions?
That's excellent.
Okay, and then within each fraction, I'm gonna see, is there any adjustment that I need to make? Are there any changes between this and this one? There's no adjustment, so I can just bring down that numerator as I see it. I'm gonna distribute this through. Any adjustment needed here from here to here? Yes, right. So what did it take for me to get from 1 to this new? It's this, right? So I need to multiply the numerator by the 2 minus x squared 1/2. And what's the nice thing about doing that? It combines together to be 1/2 plus 1/2 is 1. So that just becomes 2 minus x squared, and I can distribute the 3 through. Now I can put all this together under one fraction, because now that there's a shared common denominator, this can merge and I can combine all those like terms, and I can eventually bring that 4 plus 3x squared up. Okay, so from here to here, now I can just bring this 4 plus x 3x squared up, right? Dividing by an expression is same thing as multiplying by the reciprocal. Gonna do some more cleanup as I do that. This goes away. The reciprocal of 4 plus 3x squared is 1 over 4 plus 3x squared. Now merge all this together. Oh, minus 6. That's a change. That's outside for it. Guys, first period, you're gonna eventually have all your book bags up in the front, and then phone tucked in the wall. Guys, all your book bags up front, and all the phones up on the wall.
How many of the questions are gonna be like function rule and chain rules or like pop rule, just one? Okay. Alright, like, can we use that?
Typically, it doesn't matter, you could do B of one minus B of three over one minus three, we'll stick at the same thing.
Okay,
As long as you're consistent, you start with one, you got to get.
okay, so you'll get the same one even if I did B in front of three.
Yeah. But, calculus, clean out the, is worth something, but you know.
And then for the intervals, when you like put the function motion, you put a bracket for the zero if it's in motion.
If it's in motion,
If it's not in motion,
if it's not in motion, or if it's not part of the domain, skip it.
and then you know, on the canvas, where's the for the one where you had the graph? Is that like something like negative?
Let's see.
It was on the graph. On the on the second. This one, this one, even though it's simplification, this one's like chain rule, but this one was like.
Oh, yeah. Sorry, I redefined H and S, so that's why I did this. Yes.
So for this type of question,
Yeah, I would give you, if it's asking for vertical tangents, or the numerator denominator will just be one variable, or I'll just ask you for the setup. I won't actually just solve if there's multiple variables.
but couldn't this be like so many other ones, like √2 and -1? Okay. Oh, thank you.
Look at it.
Is it okay if I mark?
Where it's like, you gotta do that. And it's like two of them.
Yeah.